All right, let's talk real estate. You ever look at a house and just wonder, what's this place actually worth? It's a massive question, right? For pretty much everyone involved. Buyers, sellers, you name it. Well, today we're going to pull back the curtain and see how machine learning is tackling that exact problem.
So how do you do it? How do you get past just a gut feeling and really nail down that perfect price? Well, the secret, and you're about to see this in action, it isn't some kind of magic intuition. It's data. And we're going to break down exactly how that works.
And the main tool for the job? It's something called predictive modeling. Basically, it's all about training a computer to be a super smart detective. It sifts through mountains of past sales data, finds all these hidden patterns we'd never see, and then makes these incredibly smart predictions. Yeah, this is the opposite of guesswork. This is about getting real, data-driven answers. So let's dive into how it all starts.
Okay, first things first. Before any model can predict anything, it needs to learn. It needs to be trained. So you can think of this whole first part as the essential detective work, or, like the training montage in a movie. This is where we gather up all the clues and get them ready for the main event.
You've heard it before. A model is only as good as its data, and these are some of the key clues we're feeding it. We're talking about things like overall quality, the materials and finish, on a scale of 1 to 10. Then there's ground living area, which is just a fancy term for the above-ground living space. Total BSMTSF, yep, that's the total basement square footage. Even the year it was built. Every single one of these is a crucial piece of the pricing puzzle.
But you can't just dump all that raw data in. It's got to be prepped for battle. It's a three-step process, really. First, we have to handle any missing values, literally filling in the blanks in our data. Can't have any of those. Second, we do something called encoding variables. All that means is we're translating words like good or excellent into numbers that a computer can actually crunch. And finally, we scale the features. This is super important. It basically creates a level playing field, so that a huge number like lot size doesn't totally overpower a smaller, but just as important number like that quality rating from 1 to 10. You absolutely have to do this to get an accurate prediction.
All right, our data is prepped and ready. It is time for the main event. In this corner, we have a tried-and-true classic, and in the other corner, a modern machine learning powerhouse. Let's meet our two contenders for this showdown.
First up, we've got linear regression. This is the reliable classic. It works by trying to find the single best straight line that explains the relationship between a house's features and its price. Pretty straightforward. But then, on the other side, we have XGBoost. And this thing is a beast. Think of it less like one single line and more like a whole team of specialists, a bunch of decision trees. The first one makes a guess. The next one looks at the first one's mistakes and tries to fix them. The third one learns from the second one's mistakes, and on and on. It's this incredible process where the team just keeps getting smarter with every single step. So yeah, two very different ways of tackling the problem.
So, how are we going to keep score? We're using a metric called root mean square error, or just RMSE. I know, it sounds super complicated, but it's not. It's really just a fancy way of asking a simple question. On average, how far off was our prediction from the real price in actual dollars? That's it. So for this, a lower number is way, way better.
And here we go, the final scorecard. Just look at that RMSE column, the average error. Linear regression, it was off by about $34,500 on average. Not bad. But then XGBoost comes in and closes that gap to just $28,300. That's a big difference. Now check out the R-squared. Think of this as an accuracy score. It tells us how much of the price difference the model could actually explain. Linear regression got 85%, which is pretty good. But XGBoost, a whopping 90%. So looking at both scores, yeah, we have a clear winner.
So let's break that down. First up, our classic contender, linear regression. It had an average prediction error of $34,500. A solid performance, a good baseline. But then our powerhouse XGBoost just comes in and smashes that. It cut the error all the way down to $28,300. I mean, that is a huge improvement when we're talking about real-world accuracy. So, no question about it, XGBoost is our champion. But, just picking a winner isn't really the most interesting part. The real prize here is digging into why it won. What can this model teach us about what really drives a home's value?
And that's the crucial thing, right? We're moving beyond just what the price is to why it's that price. The truly great models don't just give you a number, they give you insight. So let's pop the hood on our winning model and see what's going on in there.
Okay, this is what I'm talking about. This is the cool part. XGBoost can actually tell us which of those clues, which features, it thought were the most important for making its predictions. And the results are crystal clear. Overall quality and above-ground living area, these were the absolute heavy hitters. By a long shot, these were the two most influential factors.
So what does that actually mean in the real world? It means the model figured out that the quality of the materials and the finish, plus the sheer amount of living space you have, are the single biggest drivers of a home's price tag. It learned to focus on those clues more than any others to make its incredibly accurate predictions.
There's a quote from the source material that just sums this up perfectly. XGBoost didn't just win on one front. It delivered on two. It gave us a much more accurate prediction, for sure, but, and this is just as important, it also gave us a roadmap, a way to understand why the prediction is what it is by showing us what truly matters. And that is the real power here. This isn't just some abstract academic exercise. Think about it. For a real estate agent, an investor, even just a regular homeowner, these kinds of insights can lead to much smarter, data-backed decisions. You know, things like where to invest your money on improvements or how to price a property to sell. It's incredibly practical.
Which kind of brings us to one final big-picture thought. We've just seen how machine learning can bring some serious clarity to something as messy and complex as the real estate market. It really makes you wonder, doesn't it? What other huge, complicated problems out there are just waiting for the right data and the right model to come along and crack them wide open?